Hey everybody, welcome back to Young Engineers of Today. Welcome back to Raspberry Pi and Sense Hats. We're going to do things a little bit differently, just partly because you guys can't actually see the Sense Hat doing the stuff that it's meant to do with me. I'm going to use this Sense Hat emulator, so at least you can see the output of the Sense Hat, um, you know, uh, emulated while while we're working on this, so you can at least get an idea of what your Sense Hat maybe should be doing. Um, let's see here. Well, yeah, we're going to continue with Sense Hat. I mean, you can use this emulator if you don't have it available, but it's not going to be like, the real thing. Actually, let me put that in the chat box for everybody, just in case you don't have like a Raspberry Pi available to you right now. You can use that emulator so that you can emulate the Sense Hat, see what it's supposed to do, and all that good stuff. So I believe when you last left off, you were working on displaying text, showing message and stuff like that. And we were going to expand upon that with this with oh, excuse me. Oh yeah, random number generator, so that you will again, your call. If you want to work with your Sense Hat, then yeah, you should. If you don't, if you don't have the ability to work with it, like if you don't have enough monitors or something like that, then just use the emulator. But yeah, so we're going to work with setting our letters to have random numbers, or excuse me, random colors. Um, Not entirely randomized. They're just going to be some shade of red, some shade of green, and some shade of blue. With, I believe, the exclamation mark will change. Anyway, um, yeah, changes from black to white. But yeah, so that's what we're going to get started with today. So why don't we go ahead and do that? Um, I will make this larger. I cannot. Dang. Yeah, we'll touch on some of that stuff later on, I believe. Yeah, sensing the environment, get temperature. Yeah, we'll get there too, so that you guys will have the ability to do that. But let's start with output first. Like any good programmer, you want to make sure that you're getting output. I'm actually going to zoom in on this. Too much. There we go. Can you guys read what's going on over here okay? Cool. I don't know. We'll see how much time we have. All right, so we're going to import more than just the basic Sense Hat um, library. We're actually going to import a couple more. So we're going to say from time import sleep, and from random import randint. time import sleep is going to give us the sleep function so that we can have different delays between letters. And random gives us the random, which allows us to get that random number. Like if you guys remember the guess a number game, that's random. So obviously we've got our sense equals sense hat. That just ties the sense hat to the code. And now here's where things get a little fun. So we're going to say R is equal to a random number. Oops, excuse me, random from 0 to 255. What that's doing right there is just grabbing a number from 0 to 255 and throwing it into R. Then we're going to sense.show letter. That letter is going to be O. And we're going to give it a color R, 0, and 0. So that's anywhere from 0 to 255 on the R channel. Do you guys know what these three values are right here? Yeah, but so RGB colors, you guys are familiar with that concept then? I mean, I imagine you guys probably are, but raise your hand if you'd like me to at least go over that for you. Okay, so cool. Got a few hands. All right, so RGB color. Let's actually grab a color picker. So the idea behind RGB color is, come on, color picker tool. Oh, you guys are killing me. Well, okay, so anyway, the idea behind RGB color is every single color that we can see with our eyeballs can be represented by various mixtures of red, green, and blue light. Now, this is perfect for computers because we represent all of the colors with pixels, which are tiny lights on a computer. This is different from paint mixing because that's going to be a different color model. But anyway, with lights, yeah, as we mix red, green, and blue light, if we mix them all together, we get white. If we mix, red and blue, we get like a magenta color. If we mix red and green, we get yellow. If we mix blue and green, we get like a cyan color. And those are sort of the secondary colors. And all of these can be mixed to various degrees in order to generate really any color that we can see with our eyes. So the idea behind RGB is fairly simple. So if I go back to an RGB color picker and I pick a color, let's say this nice sort of forest green color. I got this value down here, RGB, and then in parentheses 13, 96, and 56. Maybe I'll move over here to white. Oh, look, RGB 255, 255, and 255, or 0, 0, and 0. So the idea is every color can be shown, every color can be displayed on a monitor with some combination of red, green, and blue. And that's what these three numbers represent. The first number represents the amount of red. The second number represents the amount of green. And the third number represents the amount of blue. So red, green, and blue. Yeah, and that's a hex color. Same basic idea. Now, actually same exact idea, but using hexadecimal. Now, what exactly does 45 red mean? Well, it's on a scale from 0 to 255, as you can see. If we go up to pure white, everything's full blast, so we got 255s across the board. If we go down to black, there are no colors, so it's 0, 0, 0. So that's going to be 45 out of 255. So that gives you some scale, kind of. Then you got 135 green out of 255. Then you got 92 blue out of 255. And see, the thing is, you can we can actually modify these numbers manually in here. Ugh. And get these just absolutely offensive to the eye's colors. But this gives you an idea of the kind of red, green, and blue that the computer works with in order to generate the colors that we're interested in. Really ridiculously bright colors, basically. Look at that intense magenta. But yeah, so as you can see, combining them, oops, right, the left arrow key doesn't work on my keyboard. Combining them gives us these secondary colors. So we change that to 0, this to 255, and we got a nice cyan color. That yellow? The yellow is kind of bright, yeah. The idea is generally you don't want to crank it up to full oftentimes because that's just, they don't tend to be pleasant colors, but they're visible. So when we say there's a random value here in the red, if these are 0, so we can be anywhere from total black to maybe dark red to maybe a little less dark to kind of like a deep red to a bright one, all the way up to full blast, right in your face red. So it's somewhere in that value, in front to life itself. Yeah. I don't know. I think it's neato. So you thought I had forgotten. One can only hope. So yeah, so it's going to be some value of red from black to offensive red. So that's what we're putting in there. Same deal for the M. The M is going to be some value of black to crazy blue. Actually, let's make sure we throw in the sleep first. I'm not going to get ahead of myself here. So sleep 1. All right, so yeah, so we've got red, the R value filled with a random integer, thrown into the red channel, so the O is going to be some variety of red. We're actually going to, I know these are all labeled R for random number, but I'm going to try and give it a little bit better naming than that, so we're going to call it B instead for blue, because that's just the kind of person I am. I'm pedantic. So we'll do the same thing, sense.show letter. We'll make this one the M, do a comma, 0, 0, B, and sleep for 1. Same concept, except we're throwing a random value into the B channel as opposed to the R channel. And that's you can refer to them as channels if you want to sound fancy. That's not strictly necessary. I'm insufferable like that, so I'll do that. Sure. Well, I wasn't actually going to type anything yet. I was just walking through why I typed what I did. But yeah. Well, you'll be able to type faster if you type into the thing instead of the question box. GG. GG indeed. Sorry, I totally forgot to mute my mic when I did that. That was I used to be very good about that. I really apologize. I've been talking on the phone all day, and so I've been dying for some water. No, that's my bad. Normally something that isn't an issue, but just, the fact that the mic is right next to my mouth, you get to hear all of that. Okay, so once you've gotten that one, as you can probably imagine, the last one is going to go into the green channel. And same idea as before. Make sure to throw a sleep on the ends. But that should be pretty self-explanatory, right? So, once you've got all of these, though, go ahead and just raise your hand, and then we'll tackle the exclamation mark. Because the exclamation mark, we're going to do something a little different. All right, got one hand up already. 2, 3, 4. Many hands. We're getting there. We're getting there. It's like that. Can somebody help me balance my finances? My family is starving, and I can't pay my bills. And then one of them is scented candles, $3,600. Hands of Doom. All right, we're just waiting on a few more hands. Like I said, just go ahead and raise them once you finish these 3 bits here, and then we'll do the exclamation mark. All right. Okay, so that's just about everybody. Let's tackle the exclamation mark. And I know I'm giving probably more importance to this than I should, but I just want to show this off. So sense show letter, and we're going to do an exclamation mark. Exclamation mark. Now we're going to throw in a comma. What's in front of the science? Oh, gotcha. Yeah, I get you. All right, so we threw in our normal RGB colors here. However, they're all zeros right now. We're actually going to throw in another comma after it and do another set of RGB values. And I think you guys worked with this on Monday, but just in case you didn't, as I understand it, this should change from black to whatever colors in the second set of RGB. What we're actually going to do here is throw in our randomized RGB values. So now we get to see what all 3 of these colors look like when they're combined. Then we're going to sleep for 1 second and sense.clear. And once you've done that, just go ahead and hit play, and we'll get to see the result on our sense hat. Aha! So it's the area around it that gets lit up. Oh, I see. That is very, very bright. Play it a couple of times. Now you may have noticed, um, certainly on one I had here, uh, that I clicked play and nothing happened. So certainly with the emulator, the is just showing the red O. Hmm. Like over and over again? Or just the once? Just staying. Okay. Let's see here. It's interesting because that shouldn't be happening. Sleep should only be once, or 1 second. And you've got different letters here, right? I know it's a silly question, but okay. Check your, let's see here. What happens if I do this? Yeah, check your code for typos. Because it might be that the sense hat runs through everything in line, and it's hit something after the red O and run into an error. That is entirely a possibility. For everybody else, raise your hand if you've got the OMG going on. Oh, neat. Well, I'll give everybody a couple of minutes here to admire their creations. If you have any questions about anything, here. Otherwise, we can work towards trying to draw a picture with the sense hat. Picture. What's going on with yours? End of line? Like it's throwing back an EOL error at you? Okay. EOL is unexpected end of line, which means that generally, probably there is a set of parentheses that was opened but not closed. Maybe there's a comma missing. Maybe there's an open quote but not a close quote. If it gives you a line number, that gives you a little bit more information. Dang it. Is your sense hat showing anything? One curly boy without a friend from experience. Okay, so check from the first sleep and up and see if there's any like maybe you only have one parenthesis there, and there should be a second one in order to close the outer parenthesis. So if I hit play, bad input on line 9, but it would be like an end of line kind of a thing, depending upon your particular compiler. Oh, good lord, or interpreter, excuse me. There we go. Welcome back. Does it highlight any part of the code for you? Because that would be helpful if it did. Yeah, I try and keep that for the end of the class, just because I'm recording. Ah, there you go. Yeah, it's always going to be that. Um, just because that's the way we've coded it right now. However, if you really wanted to, you could do something like, and nobody has to do this. I'm just showing this off as like an example. Did you get another EOL or another error? Because that usually means that there's something else wrong with the code. Valid? That's a new one. What what are you able to copy paste with the invalid syntax? Okay, okay. Gotcha. So that means that something's spelled wrong. That is the definition of that message. Oh, I was just showing off the fact that you could randomize the color by doing that. No, Liam. But yeah, everybody else's program should be looking like that. Well, that's what I'm telling you. That's why it's not working, is because of an invalid syntax, which means that something is misspelled somewhere. So there's something else that's still misspelled in the code. And maybe Jasper. We'll see how this all shakes out. What it's highlighting sleep, it might be that um, sometimes syntax highlighters aren't always the best, so it might be the line before it. It might also just be that the uh, the error reporting isn't terribly robust, and invalid syntax could also mean that it's being fed an improper number of parameters or something like that. Basically, just it doesn't know what you mean by sleep, and then something else in parentheses when it's expecting something. I can take a look at it at the end of class just to see what exactly is going on with that. Um, but let's try drawing some things manually with the sense hat just to see what exactly um, how exactly we can work with that. So this is going to be like an entirely new program. So I'm just going to whoop, bam. And from sense hat, import sense hat, and sense equals sense hat. So that's the basic setup like we've got with all of our sense hat programs. This is going to be wild, right? Sense.set pixel 0, 2, and more parentheses 0, 0, 255. And sense.set pixel. And again, I'm going to sit on this and talk about it for a second. So if you're still typing it, don't sweat it. 7, 4, 255, 0, 0. Yep. Okay. So that's interesting. What are these? So set pixel. Let's just talk about what set pixel is. Set pixel is literally to light up one of these LEDs and treat it like a computer pixel in a way that we are specifically looking for. Set pixel takes 3 parameters. We can recognize this third one here as a set of RGB values. So this one is full on blue. This one is going to be full on red. These other 2 values are X and Y coordinates. So as we can see this little diagram here, X obviously is horizontal, Y is vertical. Now here's the confusing thing about computers. X increases as you go from left to right. Like if you're drawing on a piece of graph paper or something like that. No surprise there. Y, however, increases as you go from top to bottom. So Y increases backwards from how you'd expect it to if you're used to, paper graphs and graphing calculators and things like that. Reason for that is, originally terminals only did text, and we as humans tend to read text from top to bottom. So it would start up here, and as you typed, more things in the terminal would start appearing downwards. And that's the whole idea behind random sneeze. That's why it increases, because then all you'd have to do is just increase the line that you're writing on, the set of lines that you're writing on, in order to advance the terminal, rather than having to do the other thing, which is to figure out how big the screen is and then reverse that whole process and count upwards towards 0. I have done something incorrect. What did I do wrong? Okay, go for it.
Okay, so you can hear me. I'm blazingly loud as always. I'm back.
Welcome back.
So, technically, there's only, or actually, it's the majority of languages, mostly European, which are read left to right. Then there's a few languages, mostly the pictographic, which are read top to bottom or bottom to top. I can't remember. But then there's languages from the Middle East, which are read and written right to left. So it's not humans, it's just English-speaking countries, European countries.
You're right. You're completely right. I overgeneralized when I said humans.
So it's a politically incorrect.
Well, I appreciate that. Yes, that is true. It's not just humans. It depends. I should have said English speakers read like that, and that was primarily how a lot of computers were programmed. Were programmed for at least initially for English speakers in mind. So that's why we operate on that assumption. But yes, you are completely 100% correct. Not everybody reads that way. But yeah, so there you go. If you didn't know that, you learn something new every day. Appreciate it, Cayman. But yeah, so that's where the convention comes from, though. So yeah, we've got 0 and 2, 0, 0, 255, 7 and 4, 255, 0 and 0. So a blue pixel at 0 and 2, as we can see, 0 on the x-axis. If we were to pen this up, x, y, this is 0 and 2, and then 7 and 4, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, 7, and 0, 1, 2, 3, 4, boom. That one right there. I don't know why I drew a circle. I circled the side of it. But yeah, so as you can see, it's very easy to specifically put things like lights, pixels, where you'd like them to be. So to that end, we're going to manually create a drawing in the Sense Hat. So let me start typing this out. So sense.set pixel, boom. Sense.set, well, actually, let's just do this, and then we'll change the values each time. So 2, 2, 0, 0, 255. And then we'll actually just copy paste this and change the values as we need to. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Hey, hey. All right, so 4, 2, and full red. And then we're going to have 3, 4, and, or excuse me, full blue. And then we're going to have 3, 4, and 100 on the red, so not entirely red. So that's going to be 0, and that's going to be 100. And in fact, let's just do that. Because all of these remaining ones, the red value is going to be changed to 255. Change that to 1 and 5. And then 2 and 6, 255. And then 3 and 6. Oops. And 255. I still jumped the gun a little bit with my copy paste, but oh well. 4 and 6. Does anybody have any idea what we're doing? What we're making? Finally, 5 and 5. And 255. Any guesses as to what that is? Well, let's just find out. Play. Hey, smiley face. Look at that. Look at us smiling. Oh, sorry, I didn't see your guess there. But almost, almost. You just flipped the X and the Y, but you had the right idea. So that was a lot of typing. That was. I mean, I used copy paste, but still going in and manually changing all these values. That was not exactly, not exactly great. There are easier ways to do that. There's, yeah, it was annoying. I agree. There is another method which can set all the pixels in one go called sense set pixels. So from pixel singular to pixels plural, and we'd enter something like this. This would also take forever because I don't know if you can see this here, but these are all individual RGB values. The way sense set pixels works is it takes something called an array, which is just a whole set of values, but it takes a set of RGB values for each pixel one after the other. And so we'd have to enter that in manually, and it would take forever. So instead, we can use some variables to define your color palette. In this example, we're going to be using the 7 colors of the rainbow. So we're going to create some variables and fill them with RGB values. And let's actually bring back that color picker so that we can get an idea of what we're looking at here. So obviously 255, 0 and 0. Boom. Orange is going to be 255, 127 and 0. It's pretty orangey orange. Yellow is 255, 255 and 0. Oh, there you go. Yeah, that's true. That's true. You would sense set pixel, or you would sense clear before setting pixels in order to clear out these extra ones. How do you get rid of your firewall? Why would you want to do that? It is blocking you out of what, specifically? Your firewall shouldn't. Windows Defender. You might need administrator permissions to run it. It might be Smart Screen preventing you from running it, in which case you can usually just click like more info. It depends on what, but your firewall shouldn't have anything to do with running Python unless you're trying to run it over a network. All right. Oh my goodness. Then unless you've installed some firewall software, then idle can't start a subprocess. Because the base software that comes with it shouldn't be preventing you from being able to start it up. There are well, yes and no. Um, it can if it's trying to snag additional libraries as it's running, but it shouldn't. It shouldn't have to by default have a connection to the internet. That is. Everything that we've been using to run these programs should come with either the base Python library or the uh, the SenseHat install. Oh, it just started today? Okay. All right. Let's sense.clear real quick. Clear off the SenseHat. And let's throw in our rainbow of variables. Whoops. R no O equals. There we go. We'll just throw in the equals and then we'll equals G biv. And then there's going to be an E at the end. And the E is for basically just okay. The E is just basically a blank pixel or a black pixel, essentially. So 255, 0, 0, 255. I believe it's, 127, 127, and 0. 255, 255, and 0. 0, oops, 0, 255, 0. 0, 0, 255, 75, 0, and 130. I don't know why it added an extra space there. 159. Oops. 159, 0, and 255. Okay, take it easy, Kevin. And 0, 0, and 0. So this is our array of, or it's not really an array, but it's our collection of variables holding colors. So we've got red, orange, yellow, green, blue, indigo, violet, and nothing. Empty. And then what we can do is we can throw those into our image, and then we can sense set pixels image. So let's set up our image variable real quick. I'm actually just gonna, because this is so much typing, I'm just gonna copy paste it into the chat box so that you guys can do the same into your interpreters. Oops. There. So now you guys have that. You can just copy paste it into your code, just because it's gonna take so long to type. And you should have this nice set of things. Once you've typed that, or once you've copy pasted that rather, we're just going to sense.set pixels, plural, and feed it that image variable. And then hit run. And hey, we have a rainbow. Hooray. Ha ha ha. Anyway, so that's going to do it for today. I know it was a little bit quick at the end there. But we'll do question and answer time and poll questions, and then after that, you guys can break for the weekends and have a wonderful weekend. And we'll continue with this on Monday.